everyone. So welcome to my YouTube channel, Zenith GATE Mechanical. So in this session, I will talk about the solutions for those problems which came into the GATE 2026 mechanical paper. Okay, so first I will start with the theory of machine, and then we will move to the different subjects. Okay, so this is the question came from the gear train in the GATE 2026 paper. So a gear train with the 5 gear is shown in the figure below. The number of teeth on the each gear is N1, N2, N3, N4, and N5. The ideal gear in the gear train you have to find out. So you have to find which gear is basically a ideal gear. Okay, so there are the 4 options given: gear 4, gear 2, gear 3, and gear 1. Okay, so first of all, understood what is the ideal gear. So ideal gear means, suppose if you will write the expression for the velocity ratio in a gear train. So if any gear is not present in the velocity ratio, or we can say that it doesn't have any role in the velocity ratio, then we can say that it is a idle gear. Okay, so what we will do, we will first write the expression for the velocity ratio. So as you know that the velocity ratio is nothing but the input speed to the output speed. Okay, so input angular speed to the output angular speed, or you can write in terms of RPM also, which can be written as product of teeth on driven gear divided by product of teeth on driving gear. Okay, so how you will decide driving and driven? So for example, if you focus on this gear, you are giving the input to this, so it is driving to this particular gear. Now this third gear, which is connected to the fourth gear, so this will act as a driver gear, and this will be driven, and this will be driver for this particular gear. So what you have to write down, so velocity ratio is product of teeth on the driven to the product of teeth on the driving. Okay, that means, can I say the number 2, this gear is the driven gear, and this gear is also a driven gear. So N2 into N2 is the driven gear. So N2 is the driven gear. Now this 3 gear is basically a driving gear only. Okay, or it is driving to this particular gear number 4. So the driven gear teeth will be N2 into N4 into N5 divided by, so our product of teeth on driving gear. So 1 is basically acting as a driving gear because it is driving to the second gear. Now the 3 is also acting as a driving gear because it is driving the fourth gear. The fourth gear is also driving the fifth gear. So can I say N1 into N3 into N4 is nothing but the product of teeth on driving gear. Now you will see in this particular expression, the N4 will be cancelled out. So what you will get, N2 into N5 divided by N1 into N3. That means in the velocity ratio, if you will see, the number of teeth on the second gear, number of teeth on the fifth gear, number of teeth on the first, number of teeth on the third gear is present, but the number of teeth on the fourth gear is not there. That means the fourth gear is basically a ideal gear. Okay, so we can say the gear 4 having N4 teeth is idle gear. That means which option will be the correct? Option A is the correct answer. Okay, so this is the 1 marks question which was asked in the GATE 2026 mechanical paper. So the option A will be the correct one. Now, so there are certain important note point I want to discuss regarding this idle gear. So what are those note points? So the first one is, an intermediate gear, which doesn't have any role in the velocity ratio. An intermediate gear has no role in velocity ratio. That intermediate gear is known as idle gear. Okay, this is the first note point. So why we are using the idle gear in basically in the gear train? Because it, first of all, it basically used to fill the space. So it is basically acting as a space filler. The second thing is, if you want to change the direction of rotation, then we can use the idle gear. So for example, in a particular gear train, if you are getting as a clockwise rotation as a output, so what you will do, if you will use this idle gear, if you want to make it anti-clockwise, then you can use the idle gear. Okay. So, but in this particular question, they have asked only which gear is basically acting as an idle gear. So what you will do, first of all, you will write the expression for the velocity ratio. And if any particular gear is not have any role in the velocity ratio, that will act as a idle gear. Okay. So this is the 1 marks problem. Now let's move to the next question that is also came from the fundamentals of gear only. So the second question is, worm gear set are used for transmitting rotary motion between. So there will be a worm gear. There are different types of gear, spur gear, helical gear. So they have asked about the worm gear. So why we are using the worm gear? Worm gear are used for transmitting the rotation motion between the which kind of shaft? So the options are non-parallel and non-intersecting shaft, intersecting shaft, parallel shaft, non-parallel and intersecting shaft. Okay. So first try to see, this is basically a worm gear. So for example, the axis of this gear will be this one, which is into the plane of this particular slide. And the second axis will be this one. So if you see, the axis of the both the gears are neither parallel and nor intersecting. Okay, so please try to focus. This particular axis is into the plane of this slide. That means it is going inside, and this particular axis will be like this. So if you see this axis and this axis, which is coming out of the slide or into the slide, which is neither parallel or nor intersecting. So what we will understood from this particular diagram, so worm gear are basically used to transmit the rotary motion between the non-parallel and non-intersecting shaft. That means the option A is the correct answer. Okay, so if we want to write the points regarding the worm gear set is used to transmit the rotary motion between the two shafts that are non-parallel and non-intersecting. Okay, so the answer will be option A. So these two questions came from the gear and gear train. Both are 1 marks question. Let's move to the next question. A horizontal disc has a radial frictionless slot in which a small block is confined to slide. The disc turns anti-clockwise about its center with a constant angular velocity. They have given 3 radian per second. If the block slide along the slot with a constant speed 0.2 meter per second relative to the slot, the magnitude of Coriolis acceleration. Okay, so you have to calculate the Coriolis acceleration. So first of all, what is Coriolis acceleration magnitude? So the Coriolis acceleration is nothing but 2 times of v into omega. Okay, so omega is the basically the rotation of the link, and in that particular link, whatever the particle or whatever the blocks which is sliding, you have to consider that velocity. Okay, so in this particular case, if you see, what is the question given? A horizontal disk is there. Okay, has a radial frictionless slot. So let us suppose this is a horizontal disk. And having a slot in which one small block is sliding, fine. Or we can say that this slot contains a small block which is sliding with a velocity. What is the speed is given? Constant speed. That means V value is given as 0.2 meter per second. So it is sliding. And this horizontal disk is rotating with a angular velocity omega. And what is this angular velocity omega? Omega is also given, which is nothing but 3 radian per second. 3 radian per second. Okay. So as you know that the Coriolis acceleration is nothing but 2 times of V into omega. The velocity which is given as 0.2 and omega is 3. So what you will get 1.2. That means option A is the correct answer. Option is the correct answer. Okay. So this is also a 1 marks question. This is also a 1 marks question. Fine. Now let's move to the next question. What is the question? The rotor of an aeroplane engine has a mass moment of inertia. Okay, so let me write what is the data given. I is nothing but mass moment of inertia. Mass moment of inertia, which is nothing but 1 kg meter square. The engine rotates at a speed of 500 rpm in the clockwise direction. Okay, if view from the front of the aeroplane, that means the rpm value is given 500 rpm, which is nothing but the clockwise. Fine. If the aeroplane flying at 1200 km per hour, okay, so you can convert into the meter per second also. So the velocity which is given as 1200 km per hour. So can we say 1200 km per hour means 5 by 18 meter per second? Okay, you can convert this unit into meter per second. So how much you will get? 333.3 meter per second. Now, once this particular aeroplane which is flying at this speed, and then it is taking a turn with a radius of 2 kilometer. 2 kilometer. That means R is given as 2 kilometer, which is nothing but 2000 meter. 2000 meter. Now, what you have to calculate? Then the magnitude of gyroscopic movement exerted by the rotor on the aeroplane. Okay, so as you know that the gyroscopic movement or gyroscopic couple, gyroscopic moment is nothing but, I am denoting with the symbol C, is equal to I omega into omega p. Okay, so mass moment of inertia which is given, which is nothing but 1. Omega is also you can calculate because they have given the RPM. So how you will calculate omega? So 2 pi n, which is nothing but 500 divided by 60. Okay, so whenever you are solving these type of problem, please try to convert into the same unit because it is given in RPM. So you have to divide with 60 to convert into the revolution per second. Right? Now omega p you already know. Velocity is given 333.3 because omega p is nothing but V by R. V by R. Okay, so let me write for omega also. So 2 pi n by 60. Now these two values you have substituted in this particular expression. So 333.3 divided by what is the value of R? 2000. Once you will solve, then you will get as 8.726 Newton meter. That means it is around 8.73. So again, the option A is the correct answer. Option A is the correct answer.